So now we look at problems of section 9.3. Okay, whoops. Problem 1. All right. Physicians at a clinic gave what they thought were drugs to 910 asthma, ulcer, and herpes patients. Although the doctors later learned that the drugs were really placebos, 54% of the patients reported an improved condition. Okay? Assume that the placebo is ineffective. The probability of patients improving is 0.52. Okay, so what are they saying? 910 asthma patients, right? Of that sample, 54% reported an improved condition. So p hat, which is a proportion from your sample, is 54%. That is 54 over 100, which is 0.54. Okay. Now, you want to so you want to say whether the condition is improving or not. The chances are the proportion is 0.52. Assume that the placebo is ineffective. Probability of a patient's condition improving is 0.52. So that is my null hypothesis. The actual proportion should be 0.52. Okay, the actual proportion. Now we got 0.54. So we are the null hypothesis is the actual proportion is greater than 0.52. Okay, that's what we want to test. Question is to find the p-value. This should not be little p, guys. It should be p-value. All right. What is the test statistic for the sample, right? Sample test statistic. Formula is given by p hat minus p over square root pq over n. So p hat is given to be 0.54. P is the value that we assume to begin with over p times q. How do you get that q? That q is 1 minus p. All right. N is the sample size 910. You put all this in your calculator, you get 1.2076, so on. That is the statistic, test statistic. P-value, because this is greater, it is a right tail test. P-value is probability Z, the statistic Z is greater than the test statistic. So notice this follows the same direction as my alternate hypothesis. So I'll approximate this. Notice I need 2 digits, 2, 0. The next one is 7, so I'll approximate it to 1.21. So that's an approximation, probability Z greater than 1.21, which comes to 1 minus this. How do I get this? Right hand area is 1 minus left hand area. So you look for your areas for 1.21, that is the left area. So that's 1. 1.21 is 0.8869. So from 100% take away left area, that gives me the right area. So it should be 1 minus 0.8869. All right. Next problem. An article in the Washington Post on March 16, 1993 stated that nearly 45% of all Americans have brown eyes. So all Americans, so that's something about the population. So P, the proportion, that's the null hypothesis, is 0.45. A random sample of 78 CO5 students, that's some college students, found 30 with brown eyes. That is, out of 78 students, 30 had brown eyes. So the proportion in your sample, that is p hat, is 30 over 78. So sample size is 78. There were 30 students with brown eyes. Okay. What is the Z statistic? Well, by formula, Z statistic is P hat minus P over square root PQ over N. P hat, P, that value. What is Q? It is P, 1 minus the same P, right? So PQ over N. N is your sample size. When I put all this in my calculator, I get negative 1.1607, whatever, all that. Now, your alternative hypothesis is that your null hypothesis being not true, that is P not negative 4.45. Okay, P not equal to, so this is a two-tailed test. Two-tailed test. So I will take Z statistic is not equal to whatever we get. So this is 2 times, because I'm negative, I'm taking the left tail. 2 times the left tail. Approximate to 2 digits, 1, 6. After 6 is a 0, so I stop here. So notice, so there is a 2 times probability Z less than negative 1.16, which brings me to 2 times this quantity. Keep in mind, this is a two-tailed test, therefore you are going to have twice a certain probability. Had this been positive, you would have gone greater than. It's negative, so I'm taking less than. All right. Now, eventually, question is, how did I get this? You use your table. So Z less than negative 1.16. So negative 1.1, and you need the column of 6. Go down the column until the row negative 1.1. So here we go, 1230.1230. All right. So I will say 2 times 0.1230. All right. Next problem, I'll start on the next video. Until then,